Okay, so welcome everyone to the Heath setup meeting. Cloudy but not rainy. RASC, Halifax, I live in here long and the territory of the people. And welcome everyone to RASC and stars belong to everyone. So for today's meeting, following the photo montage, we'll have a special presentation by Tiffany Schellink, Women in Astronomy, and an encore presentation. Tony gave this talk at Nova East last year. Then Paul Heath will have Food for the Soul, and there'll be news from the board with Tony McGrath and Judy Black, and finally, what's up in June. Okay, so the photo montage, it's a little shorter than normal today, given that the weather in May was as abysmal as it was in April and March, but got a few interesting ones. So we'll start off with Jerry Black's image of M51 in Canis Venatici, the Whirlpool Galaxy. And notice there's a bunch of other smaller galaxies around in the image as well. And Michael Bochat got this shot of a sunspot just rotating into view from the eastern limb of the sun with AR 4057 on the 13th of May.
Was that the one that showed the dip?
Yeah.
Yes.
Yeah. You can kind of see the faint distortion there.
Right.
And another one from Michael, white light and hydrogen alpha images of the sun on the 27th of May. And again, Michael takes these pictures by holding his DSLR up to the eyepiece. Lots of nice resolution on the white light image, sunspots, and he caught this nice prominence as well in the hydrogen alpha image. And Earthshine on the 28th of May. Yeah, new crescent moon. Dave Chapman took the shot of the waxing crescent moon on the 1st of May. Dave, this was you just held the camera up to the eyepiece, huh?
No, that actually that's that new C90 that I well,
oh right, okay.
The new C90, but it came with the adapter from my old things.
Oh, nice.
Well, I had the T-Ring, but
yes,
so that's actually my DSLR. So I thought it turned out pretty good.
Yeah. So a DSLR shot of the moon with a small Masikov screen. Very nice. And Jeff Donaldson, Messier 13, the Great Globular Cluster in Hercules. And really nice shot from Jeff, the Crescent Nebula, NGC 6888, and the soap bubble, JU1. So there's the crescent, and it's showing up. Oh yeah, there it is. There's the soap bubble. Shows up much better on Jeff's Facebook page. Really nice. 22 hours integration time for this image. And again, Jeff's moved into monochrome imaging, so we captured different channels and then integrated them for this. Tim Doucette, a different view of Polaris, the North Star, with a bunch of interstellar dust around it. And the Flying Unicorn Star Cluster from Tim, NGC 6709. Everyone see the unicorn there? Sort of. Back legs, front legs, body, head. I don't know where oh, I guess the horn's kind of facing down. Yeah. I took the shot of the sunspot AR 4069 early May. And Merecrisium. It's kind of neat because someone mentioned that when I posted this that it looked a bit like a flatfish of some sort, the two eyes and the mouth.
Flounder.
A smoking skull.
Yeah, there you go. And inspired by Blair's presentation on black holes last meeting, I managed to catch a few shots of M87, which is a supersized elliptical galaxy with a supermassive black hole in the middle, and I was able to get the plasma jet.
Or anyone else is going to try that, it takes a surprisingly short exposure.
Yeah. And this is Blair's Leo triplet. So 3 galaxies, M65, M66, and NGC 3628. Again, urban astroimaging, Blair.
And it was actually from Synchro.
Oh, it's a St. Croix. Okay, nice. Tom McIntyre had a shot at Messier 13. And Bob Russell's been using his C-Star S50. Here is Messier 51, the Whirlpool Galaxy. And the Wizard Nebula. Bob, was this C-Star?
No, this one is not C-Star.
Ah, okay. Wasn't sure because the
Yeah,
dimensions were similar. So
Far too much detail.
yeah,
Very nice.
yeah, nice resolution, nice colors.
Thank you.
Norman Schneiderman used his C-Star to take this shot of the full moon, 12th of May. Kathy Walker captured this image of a globular cluster, NGC 5466 in Botes. And that's it. So 18, 19 images for the month. Wow. So normally we are 30. So the next time I do this will be September meeting. Do we have a meeting in September or is it the barbecue?
September 7th.
Okay. So I'll have more because I'll have the whole summer to play with.
Not if it's like last time.
But yeah, no, if it's like last time.
That'll be 2 nights.
Okay, so now we'll have our guest speaker, Tony Schellink. Come up. You're up already. And Judy Blackwell. Thanks.
I think most people in this room and out there in Zoomland are familiar with Tony Schellink. Tony is a longtime member of our center and has been very active in public observing and encouraging people to go out there and look at the stars. He loves to be an educator. He is an educator. And last summer, as David pointed out, Tony did present this at Nova East. And we felt that it was such a worthwhile presentation that the world should see it. So that's why we've invited him back, and he was very gracious in saying yes. So without further ado, Mr.
Thank you.
Schellink.
Thank you. Am I supposed to do something with this?
Yeah, clip it on your, probably about there. And then they can do a
Tasting. Can you hear me in the back?
Yeah.
All right. All right, now we have to figure out which way this goes. So, I teach quite a few courses at the Seniors College Association of Nova Scotia. One of them is how to observe the night sky with binoculars. But another course, which was designed to be a follow-up course to that, was Seeing is Believing, how the telescope changed our understanding of who we are and what we know. And so it's basically the history of astronomy as seen through the lenses of telescopes. Part of the course, I was teaching them how to use telescopes to look at the night sky. But 2/3 of it was also the historic part, focusing on how things have changed over time. And of course, there were people. Okay, I'm going the wrong way. No, that's the right way. There we are. So the So we go back, we know it all starts with astrology. So we go back 3,000 years. We start to run into people who have actual names, so around 500 BC. And here's a list of the names of people who were contributing to our advancing our knowledge related to astronomy, right up to Galileo. And this takes up the first 3 classes of the 6th class semester. And then after that, we get into these folks here, and that brings us up to today. But you'll notice there's something missing from this list of people that we talk about, and that is any women. And so, do women have any impact at all on astronomy, and do they provide any insight, any value? Well, quite a few of them did. And I hit this, but nothing happened. Let's see. There. So, before I go further, one day I'm listening to Perks and Quarks, and they were interviewing this young woman, and this was the book that was just coming out, so I rushed out and bought it, and it's an excellent source of understanding about the role that women scientists have played in developing our knowledge of the night sky, but also in other areas as well. So I highly recommend you read it, and some of my material that I'm going to talk about comes from this book. So the first person we're going to talk about is Caroline Herschel. So her brother, William Herschel, is well known by everybody, and he came to Britain to escape a family situation. I don't know what it was, but, and so he moved in, and after a while, when his sister was a little bit older, he invited her to come to Britain as well to get away from the same family situation, whatever that was. And for the next quite a few decades, the two of them worked together on astronomy. And the way it would work is William would go out with his telescope and he would point it at a particular altitude of the sky. And then he didn't move his telescope for the rest of the night. What he would do is he'd be looking through the eyepiece and watching what came through at that altitude for that night. And if something came into view, he would start yelling out what he saw and where it was and all that sort of thing to his sister, who was sitting inside the house in a warmer environment, I'm guessing. And she was recording it all. So they worked as a team in terms of observing. And that's pretty typical of women's roles for much of the history when it's related to astronomy, as we'll see. So you might think, okay, so all she did was write down the information about William, but no, she did a lot more than that. One of the things that she did is you see, William built her this telescope over here, and she used it quite frequently. So we'll see how that goes. So the thing that the really outstanding contribution she made in some sense here is to say women can be involved in astronomy and make a contribution. So she discovered 8 comets in 10 years. And if you do the math, she was discovering them faster than Messier was. So she was an accomplished observer. And but she had a lot of firsts for women. First woman to receive a salary as a scientist, first woman in England to hold a government position, first woman to be awarded the gold medal of Royal Astronomical Society. How many years after that do you think it was that the next woman won that award? Any ideas? Are you awake out there? 100 years. 100 years is right. See, that was easy, wasn't it? And she got a gold medal, and obviously doing observing and working in astronomy is good for your health because she lived to be 98 years old. So some of the things that she did is the Flamsteed, I'm pressing that catalog had come out. He was the first royal astronomer, and about 40 years earlier, he came out with a catalog that had about 2,000 roughly stars listed in it, but there was a lot of mistakes in it. And so she and William worked on fixing that. And this is the publication that came out of that, and a closer look. And so she is first author on this because one of the things that she did is, and this is again a role that women tended to play, was he did all the observing. Then you get all these observations, but what do you mean? And categorizing them or clustering them adds information or value to those observations. And that's what she did. And so she produced the errata, and she and William added 500 or more stars to the list in the process. So I decided I'd look up errata, see what it meant. Maybe you all know it, but it's good in case you don't. So she has a crater on the moon. I don't know if it's on the side facing the Earth or not. But anyway, so she's now recognized. Now, the rest of a large part of the story centers around the Harvard Observatory, which you see a picture on the left. But on the right there is the Yerkes refractor. And there are 20 people in that picture. Interestingly, there's 8 women and 12 men. And so you're going to ask yourself, well, what role did those women play at the Yerkes that they're in this picture? I don't know the answer to that, but it does say women have been involved at all aspects of astronomy over the years. So, so we're going to be focused on the Oxford observatories. And the first person here that I'm going to talk about, Anna Draper, was herself amateur astronomer, quite accomplished. Her husband's father was the first to take pictures of the moon with a telescope in something around 1840. And she was into astro imaging, but then her husband died at age 45, and she had inherited a lot of money. So what was she going to do with this money? Well, what she did is she created the Henry Draper Memorial Endowment, which for decades afterwards funded the observations going on at the Oxford observatory. So while she was accomplished, she didn't do anything herself, but she put money into this, which was very important. And she played a role throughout the history of the projects at the observatory. So if you want to hire people who are smart, dedicated, hardworking, insightful, and cheap, who do you hire? Women, yeah. So this you can see here, and do you know what they were called? Computers. These were the first computers. And and what they did is, you can see the cramped quarters that they worked in. And what would happen is at night, the astronomers, who are all happen to be male, would go out and take the images of the night sky, and then they put them together. And these women, and what you can see here is they're looking at these images very closely, and what they're doing is looking to see the size of the star image, which is a major determinant of the actual brightness of the stars. And so if you're looking at these thousands and thousands, some of these women did examine and identify 25,000 stars in their career. So they were there for quite a while. But the interesting thing is, if you look closely here, they discovered and analyzed a lot of variable stars. And this will have significance later on. All right. So the first person we're going to talk about, now there were, I have 5 women listed here. 3 of them ended up being well recognized in their time. And but one didn't, and it's strangely enough, the one who didn't get recognized was probably made the greatest contribution. So, but we'll start off with Wilhelmina. Interesting. Where did she come from? Well, she was the maid. Pickering was the one who was in charge of the observatory, and he had a maid. And his wife said, "Look, this woman is really smart. she shouldn't be a maid, she should be something else, why don't you hire him? And her, sorry, and so she was hired and she proved to be so competent and smart that she soon became the supervisor of the whole computer team. Anyway, I don't know if I have it here, but just a second here. No, okay. So Pickering says to all these women working away, I don't want you theorizing. I don't want you trying to figure out things. All I want you to do is measure, 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 and we'll get our project done. But, you know, when people are sitting there and they have all this data, regardless of whether it's on photographs or on a computer, you're going to theorize. You're going to, you know, smart people do that. And so first thing she did was develop a method of classifying stars based upon the relative strengths of the hydrogen absorption lines. And that's what those things are over down there in the lower right, as I'm sure most of you know. So she had 15 categories ranging from A to Q, and class P was for planetary nebula, and N to Q contained everything that did not fit in the other classes. So, and she classified 10,000 stars to come up with this classification scheme. So when it was published, what was it called? The Pickering-Fleming stellar classification. So despite the fact that he didn't want them, he's willing to take credit for the following classification. So anyway, let's see. Then we had Antonia, I think it's Mowry we would call that. Anyway, she was the granddaughter of John Draper. So remember, the Drapers were financing this whole thing. She actually had a degree in physics, astronomy, and philosophy from Vassar. So that's, you know, here's an overqualified person who ends up being in that little room looking at the size of stars, right? She started looking at the spectrum of star Miser A and realized that it was not two stars. So now they had, because they could analyze the spectrum of stars and realize that they were binary, that's two stars orbiting each other, they had a whole new way of identifying binary stars. So that was great. And so he published an article, Pickering, again, with himself as the author. But she had connections. Her aunt was the woman funding this whole thing, and she went to her aunt and said, this is not right, that he gets all the credit for this. And so the aunt comes over and says, hey, Mr. Pickering, or Professor Pickering, blah, 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 blah. Anyway, so after that, the papers published included the name of the woman, for the most part. And so they together, in the end, published a paper on the new stellar classification system. So then another person, Anna Cannon, she was classifying, think of this, 5,000 stars a month. You want to do the math there? That's a lot of stars. And she took the earlier one and said, no, I think we can come up with a better classification. And it ended up being OPAFGKM. And even I know this phrase. I'm sure most of you do. Oh, be a fine girl, kiss me. So that's the classification. So I think she was using a different criterion, but effectively what it was the stellar temperatures. O are hot and blue, while M stars are cool and red stars and so on. She classified 225,000 stellar spectra. Can you imagine how exhausting? How can people do that? I don't know. Anyway, and her work was published in 1918. So she was recognized in her time. She received academic honors, several prizes, and she got an honorary doctorate from Oxford, first woman, American Astronomy Society, first woman. And they created the Anne Jump Cannon Award. And one of the next people I talked about actually won that award. if you have any questions or comments, I'm happy to hear them, by the way. All right, so this is all very interesting. So we got these women, Fleming, Mara Fleming she shares a crater with another Fleming. And we end up with the two things that are really important here: spectroscopic binaries and the characteristics of stars. Now we have Henrietta Swan Leavitt. She joined as a volunteer. She was a student and then joined as a volunteer and then was employed. And again, she was doing what the others were doing, which was measuring the brightness of stars. But she, in particular, was focused on variable stars. Now, most of her life, she was ill. And though she worked for, I forget, like 22 years there, she had frequent periods where she wasn't working there, and she had to look after her mother as well. And so she would actually work from home doing this sort of thing. And yeah, there it is. I think I've already said all this. So she started working there. Shortly after that, she got ill again and lost her hearing. And so the hearing community says that, you know, this woman shows what you can accomplish even though you can't hear. She became head of the photographic photometry department, and she created a whole new way of standardizing values of magnitudes versus what they were using before, which was much more accurate and allowed them to go down to 21st magnitude. She discovered 4 novas and 2,400 variable stars, which were more than half the known variable stars by 1930. So obviously a lot of work going on there. But here's the thing. She noticed when she was looking at the variable stars, she developed a theory that said the Cepheid variables seem to, or maybe have, a relationship between their period peak to peak. Do I need to explain that? Okay, period peak to peak, that may be related to their intrinsic illumination, brightness. And she said, well, how can I do this? How can I figure out if there is that relationship? And she came up with a plan. And the plan was that they would use their Chilean telescope and point it at the Small Magellanic Cloud. And the Small Magellanic Clouds I'll show you in a second. Well, actually, let me just pause there. So when I talk about the brightness of the stars, so that what they were doing was looking at all of these, and they would say, well, this is a diameter of X, and therefore it's that bright, and this is only a diameter of Y, and therefore it's that bright. So here we have the 2 Magellanic clouds, and I'm sure you're familiar. Here we have the large one and the small one. All right, just in case you didn't know. And these are my photographs, by the way. And yeah, so what it is the Small Magellanic Cloud is 200,000 light years away. So the ones closest to us are going to be a little less than that. The ones farthest from us will be a little more, but basically they're all going to be basically the same distance away from us. And that's why she was taking pictures of them and having them do that. It was a fight for her though, because, you know, there was most of the time was spent just taking pictures of the night sky down there, and they want to get the southern hemisphere. And she had to convince them to turn it to this here on a regular basis now, not just once, but many times, in order to photograph it, so she could look at the variable stars within that. And so at the same time doing her normal job. And she was successful in that. So. So here's the issue. Up until her. If you had, let's just say a flashlight. And you pointed at you and you're 50 feet away. The observer would see the brightness of it. Then if another buddy were 100 feet away with the same flashlight and flashed at him, it would appear to be 1/4 the brightness of the nearer flashlight. But for the observer, he doesn't know whether the second flashlight is twice the distance away, or is it simply 1/4 the brightness. And so it's in just using brightness, you can't really tell distance. And as a consequence, everything we knew about the universe and all the objects there, we didn't know how far away they were. The nebula could be closer than the stars, the galaxies, or nebula, other nebula could be anywhere. They were all just up there somewhere. And that was a situation for several thousand years until Henrietta came along. And she came up with a way of measuring the distance. So what she did is, all right. See, normally I have a computer in front of me which tells me what's coming up next, so I would know that I should have hit those earlier. Anyway, you'll survive. I don't think that was supposed to be there. So here we have a variable star. Its period is peak to peak, which is 5.4 days in this case. And in 1912, she plotted 25 stars. So this was their peak, and this was their valley, and she took the time, and away she goes. And so you can see it's a very, very strong relationship between the two, the period and the inherent brightness. And the results were published, can't see it very well there, in the Harvard, whatever, journal under the name of Edward Pickering. And in it, he had a footnote that said the following statements regarding the period of 25 variable stars in the small Magellanic Cloud has been prepared by Miss Levitt. So that's all the recognition she ever received for her accomplishment. So, slight diversion. Anyone know who took this picture? No? Luna 3, the Russians. Okay. And they named 25 features on the moon based upon this picture, or another one similar to it. And at least 3/4 of them turned out to not exist, but it was a start. Anyway, there is one of the largest craters is the Levitt crater. So she is now recognized for her accomplishment. So what was that accomplishment? And there we can see it pointed out. Sorry about the red lighting. I couldn't fix it. Where are you? Should be down here somewhere.
Upper middle, right?
45 degrees from where you are.
Thank you. There it is. One of the bigger ones. I don't know who these other guys are. No one important. Okay. Now I say Shapley. Is that right?
Yes.
Shapley, yeah, Arlo Shapley. Now, the only astronomer who recognized that it wasn't Pickering doing this was Shapley. And he visited her several times. And one of the reasons he visited her was because he wanted to figure out what she was doing, how she was doing it, so he could do it. So what did he do with it? He figured out the size of the galaxy. He tried anyway. So here's the problem we had, is that the stars that are hidden by the dark lanes appear much dimmer. So you're going to assume that if you find a Cepheid variable somewhere in the dark lane, that it's much further away than it actually is. And so when he came up with his estimate of the size, he was only off by a factor of 3. But that's okay. It was still big, and it was so big that Shapley decided that that had to be the whole universe. And of course, today we think of it as roughly 100,000 light years across. So that was the first thing he used her approach to do, was estimate the size of the galaxy. But he did something else that was probably more important. What he did was he used her methodology plus others, the size and brightness of the stars. And he has 3 or 4 approaches, and he looked at the orbit of the globular clusters, and it turns out they were orbiting around a massive bunch of stars somewhere out there. Why was that important? Well, what we discovered was Toronto was not the center of the universe. What we discovered was that we are no longer at the center of the universe. We as humans just naturally assumed that we were at the center of the universe. And so he put the kibosh on that and said, no. Our universe is all of this here, and we're about halfway out into the suburbs. So we're not the center of the universe. We're in Markham. Thank you. So,
Or like Cornwall.
so that was important, but it wouldn't have happened unless she had done her thing. So then we get this other, what's his name, Hubble. And he found Cepheid variables in the Andromeda Nebula. And he then proceeded to estimate their distance away, and he was off by a factor of roughly 3 as well, but it didn't matter. Why? Because it meant that even with Shapley's bigger than it is galaxy, that meant that the nebula was outside of our galaxy and therefore was probably another galaxy. And then you got to realize by then they identified thousands of spiral nebula out there. So that meant that all of those nebula must be galaxies outside of ours as well. And he did a lot more, obviously. But what did that mean? Not only were we not the center of the universe now, but using Henrietta's approach, we now know that we're a very, very, very small cog in a very large wheel. And that the distances are, pardon the expression, astronomical. And none of this would have happened had it not been her discovering this simple relationship. So that's Henrietta. Every time I look at this, Kaposhkin, that's good, thank you, Kaposhkin. So she was doing her PhD in astronomy. Gamow, G-A-M-O-W, Gamow was her thesis advisor. And she was tasked with, and I think Shapley was on her committee as well. She was tasked with determining the composition of the sun and other stars. And she published her thesis. She had her thesis defense and published it. And her committee strongly disagreed with her results. She said that the sun was made primarily of hydrogen and helium. And they said, no, it's made of the same materials roughly as the Earth. That's what they believed at the time. And it's clear that because she was a woman, she didn't carry nearly as much weight. So she was ignored for 4 years. Then Gamow himself replicated her work and discovered she was right all along. And so and then she obviously had a career after that. But reading material, her astronomy thesis is now considered the best astronomy thesis that was ever produced by anyone. And so you can imagine now we have a whole different perception about what is our universe comprised of and where did it come from? And if we believe that the hydrogen came, you know, from the Big Bang sort of thing, it all fits together. So it was an important discovery. And now the last person I'm going to talk about is Vera Cooper-Rubin. And see what I have to say here. So she did an undergraduate at Vassar, another one in astronomy. And she applied to both Princeton and Harvard, but they wouldn't accept a woman into their programs. Princeton didn't accept women into their astronomy programs until 1975. That's the year I started my PhD, so it was interesting. So she went to Cornell and got a master's. And her primary area was studying galactic dynamics. And she faced a lot of sexism. She kept facing, and no one would ever believe that her results. So she discovered the local galaxies concentrated on a plane. And she tried to present these results, but it was rejected when she went to the conference. And it took many years to confirm her findings. Today we know it as the supergalactic plane. So why didn't people believe her? Well, you can guess. She then went to Georgetown because her husband got a job in Washington and got a PhD there, but women were not allowed in the scientific area of the university at that time. And so she had to meet her PhD advisor somewhere off campus. Amazing. She graduated in 1954 and she concluded that galaxies are clumped together rather than being randomly distributed through the universe. Now, some of you might know some of this, we're gonna look at it. But anyway, when she published her results, tried to publish her results, she was rejected and her paper was forgotten. And it took 2 decades before they confirmed that she was right. Now, I don't know exactly what her thesis was here, but this doesn't make sense to me. So eventually she became, I'll come back to it, she became a faculty member at Georgetown University. Now, this is a modern artist's impression of what our universe looks like. Galactic planes and clumps of galaxies. So her work would have contributed to our understanding of what the shape of the universe is. Now, back in 1933, a fellow named Fritz Zwicky was examining galaxy clusters. Do you see the problem here? If she discovered galaxy clusters, what was he doing examining them in 1933? I don't know the answer. Anyone here know the answer to that? Okay, you're as ignorant as I am. That's really good. Anyway, I'm confused about that. But what he said is, look, galaxy clusters only contain 1% of visible matter necessary to hold the cluster together. What is the unseen matter holding it together? But again, his results were ignored. No one paid attention to him. So along comes Vera. And there are 2 possible models for the rotation of the galaxy. One is a wheel-like one with spokes, so everything goes around and the outer ones go faster. Or it could be the planet-like rotation, forget the name of it, but where further out you go, the slower it is. And so if we look at our solar system and look at the orbital speed, we can see that it follows a very clear curve. The further out you go, the slower your your orbital speed will be. Am I going too long here? Okay. Are you staying awake? Yep. Okay. I can talk louder. Okay. So here's the results. And as you can see here, if we look at our galaxy, there's the sun, and here's the orbital speeds of the stars going out. So what this says is once you get past a certain point, the speed of the stars going around the core is independent of the distance. And so this is very interesting. And then she did further work later on where she examined the other galaxies and spiral galaxies and found the same thing. But what happens here? So how did she get these results, you might ask? Well, she was at Cornell and she got her PhD there, and they hired her on as an instructor and then eventually as a faculty member. But she was so junior that they wouldn't allow her access to the telescopes. But here she was studying the movement and structure of stars. How are you going to do it without a telescope? Well, what she did is she was teaching a night class with 6 students, and she said to them, we're going to do a project. What we're going to do is we're going to go find old, I want to call them maps of the night sky. I don't know if they're images or what. And we're going to look at the new ones, and we're going to overlay them, and we're going to look at the stars that are way out on the out here. Well, she looked at all of these, but out here, and we're going to see how much they moved based upon the old photographs and the new photographs, because you couldn't get to see it through a telescope. And so they worked all semester on that project, and then the semester ended, and they worked all summer on the project. And what she came up with was basically this graph here. So what do you think happened with this discovery? She did nothing. She published her results, and they didn't. No one believed it. It was impossible, was the phrase that she heard over and over again. It's impossible. It's impossible. And so then the question became, well, how is this possible? And the answer was, well, Zwicky suggested there's dark matter, and then she says, I'm suggesting there's dark matter as well. And the dark matter is, if you think about a ball at the end of a string and you're doing this, something's holding that ball there. And you let go of the string, off it goes. The stars are moving so fast around the outer edge of our galaxy that they should be going off somewhere. So obviously there's a string attached. Something's pulling them around and something is holding them there. And what is it? We can't see it. So it must be dark matter. Which even today, we all know that they're still questioning whether that exists or not, but anyway. And she estimated, she and her colleagues, that it was 90% dark matter and 10% visible matter in our galaxy. Now, it's not a totally sad story for her, because she went and hooked up with some other researchers on the West Coast, and they started publishing papers, and she published a lot of papers, and eventually she was recognized for the contribution she made. Here's the Vera Rubin Ridge on Mars. And so next time you're visiting Mars, you might want to take a walk up there. But here it is, the Vera Rubin Observatory. I don't know if it's finished yet, but and its primary focus is probing dark energy and dark matter. And it's in Chile, of course, and that's a heck of a telescope, right? And isn't it a bit ironic that they're building this telescope in her name, but she couldn't get access to a telescope to do her research? I think it is. Okay, so what's the situation today? Well, I could find a few stats. In 2017, 21% of physics bachelors and 20% of doctorates were women. In the same year, 33% of astronomer bachelor's degrees and 40% of astronomer doctorates were women. And as of 2021 in the USA, 27% of astronomers are women. So the slope is in the right direction. And hopefully today it's even better than it was back then. So these women made major contributions throughout history. So here's a famous quote. You may recognize it. I'll let you read it. Here's the author. Okay, what color is this house? Blue. Any other dissenting votes? Gray, blue?
Half of it's blue.
It's hard to tell with the, projection, but yeah, we're pretty sure it's sort of a bluish range, right? Okay, all right. Yes, Bob, but you saw this before. Hey, just in time. What color is this house?
To my eyes, it looks blue.
Okay, good. We're all in agreement then. What does the moon on the other side look like? Is it the same as this? 35% of the moon facing us is seas, or what do you call them? Right? And here's the back of the moon, 3%. So the thing about astronomy is we're always discovering things because on the unexpected. And our assumptions have to be questioned constantly. And what we also incorrectly tend to generalize on what we see. Well, we have no choice. If we're going to take a guess, we'd guess 35% for the back of the moon. Why wouldn't we? But it's only 3%. Galileo discovered a lot of things that were going flew in the face of common knowledge. And I don't need to go through this list. And Cassini was watching the what's it called? Something. Thank you. What planet? Mercury, thank you. And so he had a telescope pointed at the sun. He had a wall, he had it all marked off with lines and everything so that he could judge movement. He only saw the planet, I think, twice or maybe 3 times. But based upon all the theory at the time, this is what he expected to see. What did he see? He saw that. And that changed the whole idea about the size and nature of our solar system based upon that simple observation. Things are much further away than they anticipated. So I don't know, I got that. All right, there's the top of Saturn, North Pole. Who would have thought? There's the size of the Earth, roughly. Who would have predicted that? I don't know. Then we have Williams, I think his name was, pointing at nothing in the stars. There's nothing there near the Milky Way or Big Dipper where they pointed that telescope, right? Well, once he convinced them and used his power of authority to point the telescope there, that's when they discovered 3,000 galaxies and changed again our whole image of the universe. So when they sent off the Horizons, I think it was, what was it going to Pluto? What was the New Horizons. All right. That's what they expected. This is what they found. Nothing like what they expected. And of course, when they flew by and took a picture looking back, this is what they saw. An atmosphere on Pluto. Who would have possibly guessed that there would be an atmosphere on Pluto? All right, now let's come back to this. What color is this house? What do we know? What don't we know? So, it could be this. So when you're talking about astronomy, the exciting thing about astronomy, the really exciting thing is we don't know what we're going to discover. Those of us who have subscribed to magazines, you open up the first 3 to 5 pages, and it's all about new discoveries, new theories in astronomy. And that's what makes this whole study and whole hobby of such great interest. So remember the rainbow. And that's about it. So thank you very much.
Just a note of interest, all the ladies in that bottom picture that have bow ties were teachers, math teachers.
Oh, is that right?
Because the teachers were required to wear those, and that in that period of time.
Uh-huh.
And they hired math teachers for that,
Very
for
good.
that work.
Any other
All the
comments?
ladies with bow ties are actually teachers.
Anything else? Okay. Thank you.
Any questions for Tony, either here or on Zoom land?
No?
Okay, well, thanks so much, Tony. That was again enlightening and certainly encourages the young women that are out there listening to this to go and do what they want to do because it's possible nowadays. Thanks, Tony.
It doesn't make it easy.
No.
No men can use them.
Okay. Well, after that, great talk, we'll have a social break. It's 2:00, so 2:20. Okay, so 20 minutes, and then we'll have Paul Heath.
Can I co-opt the room's attention for a second for an observatory thing?
You want to?
Sure. Oh. I didn't really plan anything, but I know a lot of us are interested in the Burke-Gaffney Observatory. I have this deep desire to make like t-shirts or similar with a BGO sort of design on it. And I'm just wondering, and this is sort of the mock-up that I've got like imagined on a t-shirt. I don't know. Anyway, I'm just wondering if there is any interest from our crowd for folks to have one. The sort of thing where if you order t-shirts, it's always a little bit cheaper when you order a whole bunch of them. So I'm just trying to gauge interest and like number of sizes we should order and that sort of thing. So I've got some like paper forms that you could just write info on and give to me, or the QR code goes to an online form. I'm just gauging interest. So like, this is not a commitment. Please don't give me money yet. But hopefully if we do order shirts, then you will give me money. That's the goal. Anyway.
Do you have past presenter patches for
We can look into that. Okay, I will leave these up here.
Is that something that you can have as sort of merch for people that come through as well?
Yeah, that's exactly the idea. That's exactly the idea. Thank you for asking that. The idea is so we can order some of these, and anybody that's interested would get one, and then we would also order extras to have like public tour guests purchase if they wanted to. Yeah, so that's the goal. Cool, thank you.
Okay, so our break is up. We'll start again with Paul Heath.
Yeah.
Paul's reading today is Unnamed Rungs.
How does that sound? Can we
Yeah,
hear
can
you?
you hear me? Okay.
Can we turn the lights on?
Is,
Like to read.
yeah, well.
Well, we can't see your face.
Oh. This, I used to do this. Okay.
That better?
Unnamed rungs. Look up in wonder, the glimmering canvas full of mystery. Upon the shimmering they drew their miss, but understanding of the glimmering eludes. We built the ladder of understanding, each glowing rung proclaimed, but too often the stronger, wider rungs remained unnamed. Tasks but to polish, her fame only a fiery sword, the king proclaimed. Yet by 1,000 candles light, his findings did with patience list and organize. A task much too exhausting was declared. She with patience led, and from off the glass, individual identity was found. Each glimmering light in sequence now was named. Then within the named, strange pulsings of puzzle massed. She, with patient focus, insight and understanding drew. Her insights, the shutters wide thrown to show the vastness beyond. She a sidestep made,
and from the unnamed rungs reached high, showing to all the makeup of the glittering gems above. Another, again with patient search, from screen to screen to screen, set clear the steps of life and growth and death of those myriad distant clustered gems. While yet another within their living motion unmasked a hidden mass, their motion cast. Then with challenge, chalk, and pencil fast upon the page, the unseen, unacknowledged few help lift man out amongst the stars. The time had come. The unnamed rungs, their names now to be sung. Caroline, Annie, Henrietta, Cecilia, Sandra, Beatrice, Jocelyn, Vera, Helen, Mary, Catherine, and Dorothy, and those that led the modern search, the newest rungs, Margaret, Nancy, and so many more yet unnamed. But let us not forget to look within our house, to name the rungs who, without those names once unnamed before, could now be sung. Kathy, Mary Lou, Andrea, and Judy too.
I had about 20 names that were mentioned that are in the talk, but I figured I chose the ones that changed how we looked at the universe. So, and each stanza was one of those ladies. Thank you. Great, thanks for that, Paul. So now we have news from the board. Tony?
Good afternoon, everyone. Just a couple of items. The Scope Fund, just to let everyone know, we've passed about $3,200 in donations received to date so far for Scope. So we're very happy to see that. And I wanted to encourage everyone to think about contributing to allow us to ensure that you maintain and operate Scope on into the future. No donation is too small. So, and every donation is doubled, in fact. So it's a great opportunity. We're also very close to the astro imaging sale. We've got a few things I think almost ironed out, and we'll be making an announcement very shortly and really look forward to that part of the Scope fundraising effort as well, because there's some just phenomenal imagers in this center and some just wonderful astro images, and hopefully we'll get a chance to everyone will get a chance to own some of them for their very own. St. Croix Observing Night, the next night is on the 27th of June, so keep your eye on the discussion list for that. We've been at St. Croix a couple of times in the last few weeks, and one of the new things I'd like to let folks know is any new members, please come out. You don't need to bring equipment with you. We're very fortunate, part of the Dave Lane bequest has been some Adirondack chairs have been set up. We have a nice little area outside the roll-off where you can sit down and just spend some time getting reacquainted with the stars or learning a little bit about them and have a little chat. It's a wonderful spot just to sit and enjoy a nice evening at St. Croix.
Bring binoculars if you have them.
And if you have binoculars, thank you, Judy, bring them along.
There's equipment at St. Croix for members to use as well.
Absolutely. So you don't, if any new member who's here or listening or watching, it's a great place, and I encourage you to come out and you will absolutely enjoy your evening. I can pretty much assure you of that. We have a barbecue coming up in September, the 19th of September. So keep your eye on the list for that as well. And just finally, Nova Notes is now available on the website under the publications tab. Both Lisa Ann Fanning and John McPhee do a fabulous job. We're very lucky to have them in the center, and Nova Notes is a really a great asset to the center. So that's it. I'd like to turn matters over to Judy now.
Thanks, Tony.
What's the date of the barbecue again?
19th of September. Good question.
It's, I believe it's Friday, the Saturday night rain date, and the same thing with the following weekend. Do you have a clicker?
Yeah, right there.
Yeah, there it is there, September 19. and the rain date's the 20th, and if we get rained out both of those dates, we then have the 26th with the rain date of that weekend being the 27th. Okay, so that's the plan there. Better hit the right button here.
Down,
Oop.
down.
Yep. Okay, just want to further to Tony, what Tony was saying about Nova Notes. The deadline for submission is June 15, which is 8 days away. So if you have any articles, if you have a book you've read, you'd like to present a view on the book you've just read, please submit it. We're open to all sorts of things that members might be interested in besides photographs and news to the board. Peter and of course, unfortunately, Tony had to leave, but neither one of our Dark Sky Preserve chairs were available. So if I make an error, blame me. But it's the 16th annual DSW coming up on August 15 to 17. It's at Kensington National Park and National Historic Site. We don't have all the details as yet, but certainly they will be available on not only on our site, Linear, as well as on the Kensington National Park site. It is a public event. It isn't just meant for us. I think in years past, we've had up to 500 people or so attending some of these events at night, something along that. And we invite the park to campers to join us. We are looking for volunteers. So if you're interested in assisting in events such as we've got here, our sky tour, observing out in the field, the telescope binocular table, the solar observing, and I think, David, you are doing the solar system for that, yeah. So, but if you'd like to volunteer, please contact either Tony or Peter. And it's real easy. All you have to remember is Dark Sky Preserve. So dsp@halifax.rasc.ca, and you can contact the two of them. And the perk of being a volunteer is you get a free campsite. Okay, keep that in mind. One of the things that Peter pointed out at the last meeting, and I'll reiterate here, is that there is RASC laser pointer training that we strongly encourage all RASC members to obtain. And keep in mind, the use of those handheld lasers is regulated by Transport Canada. So to legally use them, you do have to be trained, certified, if you will. There are penalties if you don't follow those regulations. We do have an authorization of Transport Canada to use and to train others to use the laser pointers. And we do have, of course, keep in mind, it's not only the user of the laser that has to be trained, it's also the spotter. Now, as the person that's helping the person with the pointer notify, boy, there's a plane coming that direction, you have to look somewhere else right now. So there are training sessions available, and please note there is a training session at Nova East. And we are strongly encouraging all Nova East registrants to attend that session and get trained. Yeah, you may not have a pointer, a laser pointer, but you know what? You may be asked at some point to, can you please be the spotter for me? And that would be very helpful to those that are trained and want to use that laser pointer. So keep that in mind. And this is a really nice segue into Nova East. Lookout is the theme for this year. It's our 37th annual Nova East Star Party, and that's our website. There are some challenges with the work. No, it's working. Yay! It's working. So you can register now. It became live as of yesterday. It is August 22 to 25. The new moon is in dab smack in the middle of our wonderful weekend. It's at Smiley's Provincial Park. We have John Reed as our public talk for our public talk this year, and it's Stories from Space, and we'll be addressing some of the satellites out there that have been giving us some incredible science. So that's a really cool thing to be listening to. And a really huge shout out to Lisa Ann Fanning, who designed our t-shirt for us. The blue that you see in the background is actually the color of the t-shirt. Okay. And there's two kids looking up. There's the stars. There's also the summer triangle, which indicates an asterism, and also the if you look really closely, there's actually a Lyra that is actually consular, it's correct. It's up here. You can see a letter up in there. So you've got the kids looking up, you've got stars, you've got constellations, you've got the asterism, and you've also got the comet for excitement. Okay, and she put children in because it's that childlike curiosity in all of us, right, that she's trying to point out. So thank you, Lisa Ann, for that. So register, Nova East .rasc.ca is our website. And for those of you that are watching this in Zoom land, if this isn't very clear out there, please note that the video is on our website and it's also on our Halifax YouTube site. So here's the promo video, and thank you to Jerry Black for doing this. Bye. So please join us. Okay, good. Thank you. I do want to highlight, I'm gonna move over here so I can see a little bit easier. The RASC awards, you've heard me say at other meetings as well, please be cognizant of these particular awards. They're for various reasons as to why we should be acknowledging our members. So have a peek through and see whether or not there's anyone within our center that you feel should be awarded with one of those. Also, there are observing certificates that members and in the case of Explore the Universe, even non-members can participate in and obtain a certificate and pin. So have a look at those and see which ones you'd like to participate in and get that certificate. We're close to getting a certificate for one person, but otherwise our center hasn't received any observing certificates since 2022. So time to think about getting one for yourself. And for those astroimagers out there, yes, there are astroimaging programs. Some of people in our center have already obtained them, like Blair, for instance, you've obtained an astroimaging certificate, and a few others as well. And Dave Hoskin, I believe you did one for solar. So there are different application methods, and please consider where you fit within that. Last but not least, our next board meeting is not till the fall, September 2nd. So if there is anything you think of over the summer, please get in touch with us that you feel we should be addressing, and we will try to do so. Our next public meeting is the Saturday after that, September 6th, and David Hoskin will be addressing all-in-one smart telescopes. So you'll be providing us with some information and critique on some of the new smart ones out there. Also, from the national level, our next national council meeting is in fact tomorrow. And then after that will be the day after our public meeting in September. So and also you should be aware by now, I hope, of the annual meeting of the National RASC. It is Sunday, June 22nd. If you want to know the agenda, it's rasc.ca/am-2025. And if you can't remember that, just remember to log into the national site, look under the member area, governance, and you'll see the annual meeting minutes and it'll be in there. The annual report is also available. Our center's report's on page 60 something, I believe, and contained in there. But if you, to find it, you go in, again, log in under society and about us and annual reports, and you'll find the 2024 annual report there. So hopefully members will attend the meeting. There is an election of the board members and whole bunches of, and I believe there are changes as well to the bylaw and other things that would be of interest to members, including the budget. And that's it for news from the board. But before we go, there's one other thing I'd like to mention. At our March 1st, before I forget, somebody else had mentioned it, but we've got the whole summer of taking images. I believe it was David when you were talking about your montage. We have, well, this June, July, August, September, October, November. So you have 6 months to take and process your images and submit them to the center's astroimaging contest. Okay. We have the same 3 categories as the national contest, which is the wide field, solar system, and deep sky prime focus. The deadline for submission is Tuesday, November 11th. So Remembrance Day. So Remembrance Day is the deadline for you to submit your images for the astroimaging contest. The winners will be announced at the AGM in December. So, last but not least, on March 1st, we made a very special announcement. Robin Forrett from National had presented on awards, RASC awards, and following that, we announced the newest fellow to the center, and it was Paul Gregg. At that point in time, we didn't have anything to present him, but now I would ask Tony and Paul to come forward. We have Paul's plaque to present in person. So if Paul. For those who aren't aware of who Paul is, he's been a member with you at 16. They're about 16, 17, quite young anyway. He's served several roles here and in New Brunswick and at the national level. I can't say enough about you, but I'm sure that if people went and watched the March 1st video of our meeting
on the national.
And it's in the national, should be.
The
Yes.
presentation shall be in the report. And
Okay.
June journal.
Yes.
It's also written.
Okay, so in case you didn't hear that up in Zoom land, it's in the journal and it's certainly in the national report. Okay, so I'm going to hand this over to you and I need a picture, please. You have your phone. Anyway.
So on behalf of RASC Halifax and RASC National, I'd just like to say.
Well, it's a privilege to be present. So I'm really thrilled to be having the organization to present you with this plaque. Thank you for the fellowship with the alongside that. And congratulations, Paul. Good job today.
Okay.
So I believe it's your stuff.
I'll leave to do the what's up.
Okay, so now we'll see what's up in the sky in June. Fingers crossed for the nights. The title page is or the title slide is a picture of Alberio, the summer constellations. So the sun this month, well, not a lot of darkness, under 4 hours for the month. But the sun's quite high up in the sky. If anyone noticed, the moon is quite low. So it's flipped from what it is in the winter. Equinox, summer solstice, June 20th at 11:42 a.m. Atlantic Standard Time. Official start of summer. This is the sun today. It's very quiet. And a few sunspots, no big ones. This one, AR 4105, shows some promise. It has the potential for M-class solar flares, and it becomes less stable over the coming days. I get some chromal suggestions and northern lights.
Is that big filament that produced the CMA the other night?
Yeah.
Is that still on, or did that just?
No, I think it's gone. Yeah, we missed a good show. The Monday morning at 8 a.m., we had a severe solar storm, it's KB8. So, and I saw some nice pictures, Alan Dyer, nice shot that in Alberta, the other side of the smoke and the clouds. But yeah, you can see that on the national Facebook page. Nice shot. Just to remind everyone, this is the season for noctilucent clouds. June in particular is a good month for it. This happens when sunlight below the horizon reflects off tiny ice crystals, and they're really high up, 70, 60 kilometers high. It's the highest clouds that we'll see. The moon this month, we're just past first quarter of the trees fully leafed moon. Notable dates, remember what the sky was like June 1st, moon would have been near Mars. Next notable event will be the nights of the 9th to the 10th when the waxing gibbous moon will be near globular cluster 1 and 4 and Aries. And then the full moon on the 19th and the 22nd. After the last quarter, the moon will be near Saturn and Venus. And then the new moon on the 25th of June, the birds shedding feathers. Then on the 26th, the moon will be near Mercury, on the 7th near M44. And at the end of the month, very nice conjunction between the moon and Mars. So if you look through binoculars at 11:30 on June 9th, you'll see the full moon and SCA4 and Antares, all in one field of view of 7 by 50 binoculars. And at the end of the month, this is what the conjunction between the waxing crescent and Mars will 15 by 70 binoculars. They're quite close together.
Dave, does your planetarium program also do cloud forecasts?
Unfortunately, no one buy any new equipment this.
You're batting almost 1,000 for cloud covered events.
Yeah. June 22nd. This is an early morning photo opportunity. So you need to get up at 4:30 just before dawn, and the very thin crescent moon, the waning crescent moon, and Venus, very close together. And if you don't want to get up early on the 22nd, you can just stay up after sunset on the 26th, and you can see Mercury and the waxing crescent. Best nights for key off the lunar features, if you're doing Explore the Universe, are around will be around the time of first quarter, which was the 1st to the 7th. That's past, obviously. So if you're ambitious, then you'll just have to do it on the 3rd quarter, get up early in the morning, and have a really good east to west horizon, because the moon's going to be pretty low. If you didn't get this last month, you have another chance to observe Mare Orientale due to favorable westward vibration of the moon on the 16th of June. Again, you need to stay up late or get up early, because you need to look around 3:30 a.m. But it's kind of a fun object to observe and maneuver. Planets in June. So all but Jupiter, actually Jupiter is still visible. So all the planets are visible at some point in the month. But for Mercury, after the 2nd week of June, after sunset, Venus is still a prominent object in the morning sky, and near the waning crest of the moon on the 2nd. Mars is in Leo after sunset, and notably two important times to observe. On the 16th, Mars is very close to Regulus, and then, as I said, on the 29th, will be in conjunction with the waxing crescent moon. Jupiter is very low in the sky after sunset, and by the 2nd week of June, you'll have a very hard time seeing it with the glare of the setting sun. So by the end of the month, we're not going to be able to see Jupiter. Saturn rises before dawn and has a conjunction with Neptune on the 29th. Uranus emerges from the sun's glare in the east in the 1st week of June, and Neptune is visible in the pre-dawn sky. It's still in the Pisces, and this conjunction with Saturn on the 29th. So on the 16th, then, if you're just looking up unaided eye, you'll see Mars and Regulus very close. If you have binoculars or small telescope, you can take a nice picture of Mars and Regulus. The colors will be very contrasting. So Regulus is a blue-white star. Mars is going to appear orange-red. And Regulus is also a double star. So you can catch the companion of Regulus as well. And this is what you'll see on the 29th, at 3:30 in the morning. Saturn and Neptune in the same field of view in 15x70 binoculars. So if you haven't seen Neptune, this is a good chance, because you'll know exactly where to look. Explore the universe through the summer constellations. We only have about 4 hours of true darkness to see stuff in the night sky in June, but twilight ending at 11:30. It's somewhat dark by 10:30. So the summer constellations are Cygnus, Lyra, Hercules, Gila, Sagittarius, Scorpius, and Capricornus. Oh, just a hint. If you're trying to find locate the keystone in Hercules, draw a line from Vega to Arcturus in both cases. And it will, that line goes right through the Houston. Summer stars, Vega, fifth brightest star, in the sky, followed by Altair and Unamed, and Brazil Gimpi. In your neat sky object for June is the coat hanger asterism. Here, also known as Brocchi's cluster or Colander 399. To find this asterism, simply go about a third of the distance from Altair there to Vega. With binoculars, it's easy to find, and it looks like it says it's a coat hanger. If you're upside down, though, in our from our orientation, our latitude. And your double star, it's actually a triple star. The optical triple star system is Omicron 1 Cygni. So, fluid constellation Cygnus, and just above the cross, Omicron 1 Cygni. It's a really neat triple star system. Red, white, and blue. So Omicron 1 Cygni is a red giant star. 30 Cygni is a white star, and HD 192579 is blue. And you can see they're all at different, dramatic, quite substantially different distances from the Earth. So that's obvious. This is an optical double star. Kind of neat. Judy knows all about this one. So Steve. And the challenge, getting up early. We do have a meteor shower, the Perrytids. They last from May 29th to June 17th. The radiant, the peak, the predicted peak was during the daylight hours of the day, June 7th. Well, clouds. No one was going to see it if we hadn't had clouds. And in fact, if we have a clear sky in the next few days, it's still worth getting up just an hour before dawn. And at that point, the radiant will be above, well above, but above the northeastern horizon. And this is a pretty active meteor shower, 60 to 20 meteors per hour. But you only have a short time to see it before dawn. Now, you can use a radio to hear meteors. And if anyone's interested, you can go to the What's Up on the Halifax RASC website and click the link, and it'll tell you, this is an article, I think it's in Sky and Telescope, how to listen to meteors with an FM radio.
Or get in touch with Mike Bush.
Or get in touch with Mike Bush. Another item you can take off for if you're doing a sort of universe is some artificial satellites. So the program requires you to observe at least one Earth orbiting artificial satellite. The International Space Station is an easy one, and you don't need a telescope or binoculars. It's very bright, unaided eye. If you go to Spot the Station, NASA, you can put in dates and times for when the ISS will be passing over Halifax. Astrospheric, I believe, also lists times when you can see the space station.
Heavens above as well.
Heavens above. Okay. So easy to take a picture. Like this is short exposure with the DSLR, and you can see the streak of light, how fast it was traveling. This is a couple second exposure. And if you're feeling really ambitious, try to take a picture of the space station.
Does it have to be the space station for
No.
you, or it can be any like a link
And
satellite?
anything, yeah. I think it's I forget the name, the Chinese satellite. Oh, remember the name, Shandong? That one's also pretty obvious. There's others.
Can I add
Oh.
something?
Yes.
The Spot the Station website that I love so much is no longer going to be up June 12th.
Courtesy of our friend in the White House.
Yes. But indeed, they instead recommend that you download their new app. Which sucks because I use that website all the time for
Yeah.
Spot the Station is no longer going to be on.
Okay, so those out in Zoom land, Tiffany was just noting that the Spot the Station website is no longer going to be available. But there is an app.
Would we just be able to call the president and ask him?
He probably wouldn't know what it was.
That's, I think it's a dog.
What was the exposure on that, your photo?
I think it was a couple seconds.
I meant the one on the right.
This was I got this with my, using my 12-inch dog. I had to manually track.
And a video?
And a video, and I took, I think out of the several hundred frames, I had like 20 that had the station in it.
But you were
this is the best one. What's up, Larry?
You were tracking it, not just waiting for it to go through.
Does your mount do a smooth track for that, or is it just
No.
move ahead and wait, move ahead and wait?
Well, I'll try to keep it on with it through the binding scope. I haven't tried it again since then.
You see the one yesterday or this morning, they were taking through the smoke on the move, as across the move.
Oh, no, I didn't see that.
Apparently it stabilized the atmosphere above wherever they were taking it. The smoke made a steady atmosphere.
Right?
And they got a really sharp,
cool.
clear image of the ISS over the moon in daylight.
Neat.
But it didn't say on the photograph what size telescope they used.
Or how much smoke they required.
Yeah.
Well, it's somebody out west that did it, so there's smoke.
Yeah. Where did you see that?
It was on spaceweather.com.
Okay.
There either yesterday or this morning.
Right. So if you didn't hear Paul, if you go to spaceweather.com, either today or yesterday, we'll see a nice shot of the ISS in the day.
There are some planetary imagers that just get phenomenal shots of the space station.
Yeah.
One of them is even result an astronaut on space.
Yes, I saw that. Yeah. And that's it for what's up in the June sky. We don't have meetings in July and August, but I will prepare what's up in July and August, and Jerry will post it on the Halifax.
Not a question, but I just wanted to mention the full moon that's coming up. Full moons around the solstice are generally quite low in the sky when they culminate. But because of the nature of the moon's orbit, we're at something called a major standstill. And it's going to be the lowest full moon like for the last 16 years, or 18 or something like that. So if you watch the full moon come up, it's going to be very, very low down. And if you want to know what a standstill is, Judy knows. You can ask her.
Okay, so if you didn't hear that Zoom land, Dave Kaplan was saying that the full moon this month is going to be the lowest in 60 years.
Yeah.
And so really low, it's low to the horizon. So have a good horizon, low horizon to see it. And Judy, if you email her, she can tell you what it needs sense.
Yeah, email, please.
Okay, so there's no questions. Thanks, everyone, and see you in September. If not, at Dark Side Weekend or Nova East.
Thank you, David.
Thank you.
Please hang up and try again.